Great question. Instead of viewing this number as a static linear count of possibilities, we can harmonize it with its compounding nature by shifting our perspective toward probabilistic distributions, entropy, and structured selection models. 1. Factorial compression via logarithms. Since factorial growth is explosive, we can log transform it. Log 10 303C50 approx 57.773. This tells us the order of magnitude, how many digits the number has, rather than its raw scale, making it more interpretable. 2. Probabilistic interpretation, likelihood of a specific set. Instead of brute force counting, we can ask, what's the probability of randomly selecting a specific set of 50 projects? P specific set equals frac 1 303C50, approx 1.87 times 10 to the minus 58. This is near zero, showing how vast the possibility space is. Nashri 3. Combinatorial entropy, measuring information content. We can compute the Shannon entropy to express the randomness in bits. H equals to log 2 303cc50. H approx 191.6 text bits. This means you would need about 192 bits of information to uniquely specify one of these combinations. This is like encoding it in a highly optimized digital system. 4. Symmetric compounding perspective. Rather than viewing this as picking 50 out of 303, we can flip the lens. What if we grouped all possible selections into clusters? How does each subset of 50 interact with overlapping subsets? If we considered hierarchical clustering, could we reduce the choice space into meaningful bundles? Using graph theory, we could structure all 303 projects into nodes, then analyze how different subsets overlap and which subsets naturally cohere. This would allow for harmonic bundling rather than brute force selection. 5. Emergent patterns, fractals and higher order structures. Rather than treating combinations as a flat, random space, we could examine whether these project combinations follow certain fractal or recursive patterns. Do smaller groups of projects naturally form clusters that appear across selections? Could we reduce the choice space using self-similarity and network resonance? By shifting from brute combinatorial logic to a structured, harmonic approach, we could find hidden order within this probabilistic explosion. TLDR, transforming chaos into structure. Instead of seeing 30350 as an incomprehensible number, we can use logarithms to compress factorial growth, analyze selection probability to grasp the rarity of choices, measure entropy to understand its information complexity, use graph-based clustering to reveal hidden structures, explore fractal or self-similar properties in the dataset. This shifts our thinking from linear explosion to harmonic emergence, a probabilistic landscape that can be mapped rather than brute forced.